So remember to say this topic, ethic geometry, it is examinable both in paper 1 and in paper 2. Okay? So meaning that we need to spend time or to invest our time with this topic. Otherwise, it will hunt us in both papers. So in paper 1, remember, you are not allowed to use a calculator. However, certain concept which has been asked in this question, I'll be going a step further just to explain here and there, especially on time calculation. Okay, so right now, let me share the board with you. Just a minute. Oh, the board is already shared. As we are used of, let me share the board. Forgotten that I've already shared it. Okay, let me go and start explaining now. All right. So this is the Venn diagram. This is our F. This is our graph. Okay, of which we have point A, B, C. Okay, we have these points. And then the first question is saying, if the local time at B is 15 hours, what is the local time at C? So we need to identify where B is. You can agree with me to say this is B. So they are saying the time at B is 15 hours. If the time at B is 15 hours, what can be the time at C? So remember that we live on Earth, on planet Earth. Okay? And whatever calculation that we are doing, if we reflect them to the real life, okay, they are the true reflection of what happens on the real life. So with respect to time, I'm sure you have seen a situation where, for example, in another country, especially out of Africa, maybe they are watching or playing a football match maybe around 17 hours. But here in Zambia, that 17 hours for other country, for us, maybe watch the same match maybe around 23 hours. So what is the difference in time? Or what makes us to have difference in time? What matters? Or what are we supposed to do for us to calculate the time? If at all it's a 15 hours at point B, what can be the time at point C? So the first point which I want to highlight to you is that whenever we are doing time calculation on the Earth, we normally use the longitude. Okay? So we use the longitude to do or to calculate time. What are longitude? The lines that move from north to south. So we use these lines, not latitude, no, but longitude. That's the reason why I've been emphasizing on the matter of us knowing or appreciating longitude and latitude. Okay, so time calculation, we use longitude to calculate time. So now what are we supposed to know about time calculation? What you're supposed to know is that places that are situated on the same longitude, they have the same time. So for example, if at all we have a country here, okay, country A, it's here, and then country B, it's here. Provided they are on the same longitude, it means that these countries, they're going to have exactly the same time. If at all it's 12 hours right now, even the other country it will be 12 hours. But if at all we have another country, C, for example, here, so you will find that the time at B is different from the time at C. Here in Zambia, for example, right now, it is 16 hours. You may find that to other countries, they are sleeping. Maybe it is 01 or 24 hours. Or to other country, it's actually morning, maybe 6 hours or 7 hours. Okay? So the reason why we have different time is because of the countries are situated on different longitudes. We need to appreciate that. Okay? However, even more information on this, I shared the link concerning the time calculation. I think I did share. If not, I'll try and cross-check so that I can share the link to my YouTube channel where I've explained about time calculation. So now let me go back to the question. The question is saying, if the local time at B is 15 hours, what is the time at C? What is the time at C? Yes, Billy, your hand is up.
Yes, sir. So you said that if if the places like if like for example where there's A here and B, you said if they're the same, if they're on the same longitude path, the time they need to be the same. What
Yes.
if does it mean that it doesn't consider whether ya jumpa line where at equator? Yeah, this
Okay.
one.
Okay. That one doesn't matter. Whether it's on the top part of the earth or on south part of the earth, provided it is along the same longitude, we're going to have time. So in short, when we are dealing with time, don't consider the latitude in any way. The only thing that we consider is longitude. Okay? Regardless whether the point it's on the south or the north, the time will be the same. But immediately when you go to another longitude, okay, the time will be different. Okay? And maybe I can further explain to say, normally, as you are going to the east part of the earth, the countries which are on the east part of the earth, they are ahead in terms of time. Okay? These countries are ahead of time. The countries which are on the west part, okay, they are behind with time. So that's the reason why, even when we're doing the calculation, if you are moving toward the east, you need to add. If you are moving toward the west, you need to add. Now, what are you supposed to add? I'm going to explain now. Okay, as I start question A. So let's go back to question A. If the local time at B is 15 hours, what is the local time at C? So let's go to the Venn diagram. So this is the Venn diagram. Okay, we have B and C. So in short, I can make a summary of the diagram by just drawing the longitude. Okay, to say we have these two longitude. The other longitude, that's where B is. And then the other longitude, that's where C is located. Now we need to know the value of this longitude. Okay. So the longitude for C, if we go on top here, it is 75 degrees east. Okay. So I will say this is 75 degrees east. Then the longitude for B, if we go up here, it's 30 degrees west. Okay. So B, it is on 30 degrees west. Sorry, I wanted to write east. Let me just write west. Okay, like that. Okay, so however, before I solve, is there anyone with a question? Anyone who is behind before I start solving now? Before I start explaining? Okay, I'm sure we are okay. So now, the question is saying the time at B, it is 15 hours. Then we want to find the time at C. What are we supposed to do? Okay, what are we supposed to do for us to find the time at C? So what we are supposed to do is that first of all, we need to know the time difference between point B and point C. We need to appreciate the time difference. Very important. I'm emphasizing this. We need to appreciate the time difference between point B and C. So to find the time difference between point B and C, we first need to find the difference in longitude. We need to find the difference in longitude. So now since B is on the west part, C on the east part, what are we supposed to do for us to find the difference in longitude? What are we supposed to do? To find the difference in longitude, what are we supposed to do? Madam Faustina, what do you think? What are we supposed to do?
So you is it you subtract when they are well you add them when they are in different. Hey. Yeah. But you're supposed to add.
Okay. So we need to add if at all the points are on different part of the athine. So meaning that we'll say 30 plus 75. Okay? And then when we add 30 plus 75, you agree with me to say that the answer is 105 degrees. So this is the difference in longitude. So now after knowing the difference in longitude, we need to convert this 105 degree into time. Okay? We need to convert this 105 degree into time. How? Normally, there's a relationship, okay, which says that the Earth rotates every 24 hours, which is a day, okay? The Earth rotates 360 degrees in 24 hours to make a day, okay? So we have 360 degrees of rotation to make one day, which is 24 hours. This is a true relationship which is there. Those who have done geography can agree with me. Of which now when you reduce this relationship, okay, we divide by 24, we are just trying to reduce it, okay? We divide by 24, you will find that 24 into 360, the answer is 15 degree. 24 into 24, the answer is 1 hour. So in short, every 1 hour, we have a 15 degrees. Or every 15 degrees, we have 1 hour. Okay? So meaning that we use now this relationship. So for you, what you're supposed to know is just this relationship here to say, in 15 degrees, you have 1 hour. This relationship that you are supposed to know. And in 1 degree, you have 4 minutes. In 1 degree, you have 4 minutes. So now let's use this relationship to find the time in 105. So now since we are saying 15 degrees is equal to 1 hour. How about 105? How many hours are there? We shall say x, and then we'll cross multiply. 15 degree times x, you agree with me to say the answer is 15 degrees x is equal to 105 degrees times 1 hour, it's 105 degree hour. We need to appreciate this calculation which are happening here. Okay? However, before I go further, Bill's hand is up. Yes, Bill?
No, sir, it's okay. Although I just wanted to try, but it's okay.
All right. Okay. So now, at this stage, we can divide by 15 degree, so that we know the value of x. Okay, so x is equal to, so 15 into 105. You agree with me to say the answer is 7. So this 7 is 7 hours. So this 7 hours, what is it representing? Remember, initially, we have calculated the difference in longitude, where we added 30 plus 75 to have 105. After calculating this difference in longitude, we said we need to know the difference in time with the help of knowing the difference in longitude. How can we convert this 105 degree into time? The only way we can convert that is by using this relationship which we have said. In every 15 degrees, we have 1 hour. This relationship here. In every 15 degrees, we have 1 hour. How about 105 degrees? How many hours are there? You make it is equal to x. Then when you cross multiply and then you find the value of x, you find that our answer is 7 hours. So this 7 hours, in short, is 105 in degrees. We have converted 105 degrees in time, which is 7 hours, using this relationship which is here. So now this simply means that if we go back to our Venn diagram, okay, it simply means that the difference in time between point B and C, it is 7 hours. Now, what is the time at C? So as I said, if you compare the position where B is and C is, you agree with me to say C, it is on the east part. Or in short, when you are at B, here at B, or on C, you'll be going toward the east. Toward the east. And going toward the east, we need to add the time. Okay? Just in case you forget, I'll do this. We have the west, we have west, and then we have east. Okay? So now if you are going, for example, where B is, we have B here, and then if at all we have another line here to say A. For us to move from B going to C, we need to subtract time. For us to move from B to C, we need to add time. So in short, when you are going towards the west, what do we do? Okay? What we are supposed to do is we say we eventually subtract. Okay? Subtract time. However, when you are going toward the east, what do you do? Okay, we just say eventually add some time. Just in case you forget, we can use this. Okay, on the east, eventually add some time, and then west, we eventually subtract time. So now, what are we supposed to do in this case? We have B, the time at B, which is 15 hours. The difference in time is 7 hours, and we want to find the time at C, whereby when we are at B, to go to C, we are going toward the east, so we need to add. What we're going to add, we'll add 15 hours, plus 7 hours. 15 hours plus 7 hours, okay? Of which we have 0, 0, okay? The minute side we have 0, 0, and then 15 plus 7, you agree with me to say it is 22. So meaning that the time at C, it is 22 hours. So 22 hours is the time at point C. Now let me receive questions now so that I can clarify where possible. Yes, Billy.
Sir, me, I'm lost on the 15 hours. Where did it?
Okay, so this 15 hours, Billy, it is part of the question. Okay, let me go back to the question there. Let me go up to the question. So the question is saying, if the local time at B is 15 hours, what is the local time at C? So the 15 hours, Billy, is given. Are you okay with Billy? Give me feedback. Okay, thank you very much.
Yes, sir.
All right. Okay. Any other question for me? Who is behind with time? Or with question 1, question A? Yes, Madam Faustina, where are you behind?
Sir, you don't know, my network is tripping here. You're going online again. I think you can kindly go through as maybe just summarize it, not really going back one, but at least summarizing it. Starting from the 360 over 24, Snamvede Chabine.
Okay, all right. Let me do so. Let me give a summary of explanation. The question is saying, if the local time at B is 15 hours, what is the local time at C? You need to go to the diagram. Okay? In this diagram, we have B and C. And I said, let me extract this B and C and create independent lines. Okay? After doing that, I'm having this diagram or these lines. We have this line and this line here. With line B, we identify to say 30 degrees, it is a longitude passing through point B. 75 degrees is a longitude passing through point C. Now, after identifying the longitude, we need to find the difference in longitude. Since B and C, they are on different parts of the earth. The other one on the west, the other one on east. We need to add. That's the reason why we added it to have 105. To have this 105. Now, after knowing the difference in longitude, I said now we need to know the difference in time. Since the difference in longitude is 105, let's convert this 105 degrees into time. That's where now that relationship comes in. So about 360 to be equal to 24 hours, I used it for you to understand where the relationship is coming from. However, Madam Faustina, what you're supposed just to know is that in every 15 degrees, you have 1 hour. Okay? In every 15 degrees, you have 1 hour. The 360 is equal to 24 hours. I just used it for us to derive at this relationship here, so that you can see where it's coming from with respect to the geography concept that we had received long time ago, to say in 1 day, the earth rotates 360 degrees. Okay? In 1 day, the earth rotates 360 degrees. In that 360 degrees, since it's 1 day, it's making 24 hours. So that's the reason why we had the 360 degrees is equal to 24 hours. When you reduce this, you have 15 degrees is equal to 1 hour. Okay, so now what you are just supposed to know is this during the final exam. No need of showing this relationship here, unless when you forget about this, then you can use this. Even this, it will give you the same answer. Okay, so now since 15 degrees is equal to 1 hour, how about 105 degrees is equal to x? Okay, so after cross multiplying and finding the value of x, we found that the value of x is 7 hours, which is here. It's 7 hours. So this 7 hours is representing the difference between point B and C. The difference in time between B and C is 7 hours. Furthermore, now that we know that the time at B is 15 hours, that's what we have been given in the question. The time at B is 15 hours. What's the time at C? Now, since we know to say for us to move from point B going to C, we are moving toward the east part, then we need to add. If you are moving, for example, B going to where A is, what the west part, you need to subtract some time. Now, since we are moving from B going to C, we need to add. So we'll add 15. We'll add 15 plus 7 hours. When you add 15 plus 7 hours, it is the 22 hours that we are having, which is the time at point C. So that is just a summary for you, Madam Faustina. Hope you have gotten something from there. Thank you very much. Okay, so now we can go to question B. What is question B saying? Okay, let me go on top here. Question B is saying, it takes a plane 6 hours to fly from A to B. What is its speed in knots? So before I solve this question, let me explain about these units called the knots. However, if you have watched those links which I have shared, there's just a video which I explained about the SI unit, or the units that we use under earth geometry. In mathematics, the units that we use. There's just a video just about the units. Okay? However, let me try and highlight a bit about knots. What do we mean by knots? Okay? Remember, first of all, to say speed, the formula for speed is distance over time. And the units for distance, we said we have the kilometer and then we have the nautical mile. Now I'm interested in nautical mile. Okay? So if your distance is in nautical mile, where you say nautical mile over time, which is in hours. Okay? This nautical mile over hours is what we are referring to as the knots. So in short, what I'm trying to communicate is 1 nautical mile per hour is equal to 1 knots. Is equal to 1 knot. 1 1 nautical mile per hour is equal to 1 knot. We need to know this relationship here. 1 nautical mile per hour is equal to 1 knot. So in short, when the question is saying calculate the speed, okay? If it takes a plane 6 hours to fly from A to B, what is its speed in knots? Listen, the speed in knots. So meaning that, in short, just try to calculate the speed in nautical mile per hour. When you do that, then you just convert that nautical mile per hour into knots. Okay? So with this information which I've given you, then what we're supposed to know is the distance between A and B in nautical mile, not kilometer. So before I solve question B, is there anyone with a question with what I've explained? Is there anyone with a question with what I've explained, or are we okay? Give me feedback. Madam Juanita, are you okay? Madam Juanita, give me feedback. Are you okay? Okay. Billy says he's okay. How about Rachel? Rachel, are you okay? Okay. All right. Okay. Most of us, we have said we are okay. Then let's continue. So now I'll go back to the question. Okay. Remember the question is saying it takes a plane 6 hours. Okay. 6 hours to move or to fly from A to B. What is its speed in knots? Okay. Let's go to the diagram. Where is A in this diagram? So let's first locate where A is. Very important. Okay, we need to locate where A is and where B is, and then we ask ourselves to say, is the distance along latitude or along longitude, so that we know which formula to use. Okay, so now A and B, they are along the longitude. So meaning that we need to use the longitude formula. Okay, we need to use the longitude formula. Let me come this side. We need to use the longitude formula where we say distance is equal to theta over 360 times 2 pi calculator r. Now, if you remember what I told Rachel yesterday, to say with paper 1, avoid using this formula because you're not allowed to use a calculator. Okay? As a result, we came up with the formula for distance along longitude if you are dealing with what? Nautical mile, where we say distance is equal to theta times 60 degrees. This theta is a difference in latitude. So A is on latitude 60 degrees north, B on latitude 30 degrees south. Since they are on different part of the earth, then we are going to add. So if you add 60 plus 30, the answer is 90. So meaning that we say distance is equal to theta, it is 90 degrees times 60. So we say distance is equal to, remember this distance is the distance between point A and B. And don't use a calculator because you are not allowed to use a calculator. So now we need to multiply. What is 9 times 6? You can agree with me to say the answer is 54. Okay? So I'll write 54. And then we have 2 zeros. 1 0 from 90, the other 0 from 60. So mean that the distance between A and B is 5,400 nautical mile. This is not our answer. This is just the distance between point A and B. Let me pause here. Is there any question for me? Madam Faustina, are you okay? Do you have any question for me? How about Mr. Charles?
No, sir, I'm following bit by bit, yes.
All right, okay.
90, 60.
All right. How about Mr. Charles? Are you okay so far? Do you have any question for me?
Sir, I got a little bit lost because I walked out. I'm at work.
Oh, okay.
I was attending to something.
All right.
Yes.
Okay.
But I just pray you share the video as well so that I catch up somewhere.
Definitely, I'll do so. Thank you very much, sir. Thank you. Okay. So the distance AB it is 4,400 kilometers. Now this is not the final answer because we are looking for speed. So now we'll go to the formula for speed. Speed is equal to distance over time. The value for distance we have calculated it is 5,400 nautical mile over the time taken. If we go back to the question, there's a time taken here. To say it takes a plane 6 hours to fly from A to B. Okay? To fly from A to B. We need to appreciate that. Okay? So mean that the time taken it is 6 hours. So I'll say over 6 hours. Like that. We need to appreciate. Okay? Now if we divide now, let's divide. We'll say speed is equal to 6 into 54. Okay? If we divide 6 into 54, you agree with me to say the answer is 9. So I'll write 9. Then 6 into zeros, the answer is zeros. So speed is equal to 900 nautical mile per hour. But the question is saying find the speed in knots. So now we'll say therefore speed is equal to 900 knots. Okay, so we'll just remove the nautical mile and substitute 900 knots. So remove nautical mile per hour and put knots. Any question for me? Any question for me? Okay, Billy says it's okay. Yes, Mr. Emmanuel, your hand is up.
Sorry, I've just joined. I've just seen that we're having class at 15 hours.
Oh yeah. Okay.
So I'm behind in everything now. Don't know if this video will be sent or not.
No, it will be shared definitely. Definitely. Every lesson that we are actually having, because of the 20th quarter that we agreed upon, it's my duty for me to share the videos. So I'll definitely going to share it. Once I'm done, I'll try to download it and then upload it so that I can share it with you. Definitely I'll share it. Okay, otherwise guys.
All right, sir. Thank you very much.
All right, you're welcome, sir. You're welcome. Otherwise, guys, if at all there is no any question, this is what I wanted to share with you with paper 1 as far as Earth geometry is concerned. So mean that we can say bye-bye to Earth geometry, right? What is your views? Should we start another topic? Yes, Madam Waneda, your hand is up.
I think, sir, you just give us another example of paper 1.
Okay. Another example.
Then we can, yes, then we can move to another topic.
Okay. All right. Okay.
Yes.
So then, okay. Yes, Billy, your hand is up as well.
Yes, concerning Earth geometry, I think you can just exercise it.
Exercise, huh? Okay, all right. So what I'll do is this. I'll give you an exercise. Okay? Give you an exercise, preferably today. And then tomorrow, we shall discuss paper 1 as well, Earth geometry, and then give an exercise. Okay? And then from there, we shall start trick. And then let me just cross-check if at all I shared the link concerning time calculation. If I didn't, then I will share them. And please, just find time to watch those. You are going to appreciate. You're going to appreciate because I've explained them very well. Okay, so we shall move in that direction.